Hey everybody, Trey here. Welcome to another video on the channel. We've got a pretty potent winter weather storm system to talk about here from parts of the southern plains into the northeast, expected to begin tonight and go through about Thursday into early Friday morning for much of the country. Now, we don't do a lot of winter weather forecasting on this channel. My knowledge of severe weather forecasting is a lot greater than it is for winter weather forecasting, but I thought this event had a few different interesting features to it, interesting characteristics. So wanted to talk about those briefly and kind of go over the background synoptic environment and how it might progress, as well as some possible outcomes for this system. So let's get started here. Let's look at our satellite view. You can see we've got kind of this big, broad trough here across the western half of the United States. It's got this kind of little shortwave here associated with it up in the Great Lakes region, a little shortwave down here in the Gulf of Mexico, and a little swirl out here, big swirl out here in the Atlantic. But this long wave trough here is going to be our main player for our winter weather system here the next couple days. And you can see this kind of surge of clouds coming down here into the northwest. Well, that's associated with a little bit of a belt of enhanced winds here on the backside of this trough. And as that digs down, it's going to help this trough dig down and kind of become a little more amplified, a little more negatively tilted as it ejects into the southern plains tomorrow into Thursday. And that matches up pretty well with what we're seeing on our upper level upper air maps here. This is our 500 millibar chart here from this morning, and you can see this is all part of really one big, broad, long wave trough here. We've got kind of a short wave axis here where we saw that trough in the Great Lakes region. Another little short wave in here, very positively tilted. That's associated with this jet streak back here up digging into the northwest, and this is going to be our main player again for our winter weather system. It's going to dig down, amplify. It's going to be positively tilted for a while, but as we go toward Wednesday evening and Thursday, when our forecast winter precipitation totals are supposed to be at their highest, at their peak, that's going to start to become negatively tilted as it ejects into the southern plains. Let's go down to 700 millibars, and we can see these kind of individual short waves a little bit better. Very potent one up here, Great Lakes region. Our sort of positively tilted one here across the sort of California, Nevada, Utah area. And then one here across the Texas Panhandle, and that may bring a little bit of precipitation to the southern plains here to start things off today. It'll start off as rain, and then some very cold air will filter in from the northwest. And we'll talk about the surface pattern here in a second. And we should probably have a wintry mix here for the southern plains this evening. More so snow as we go up closer to the source of the colder air here up into the central plains. Should see some mostly snow here this evening. A little bit of a mix down here in North Texas and Oklahoma. But this shortwave back here is going to be our main player for our winter weather event. Again, it's going to amplify and become a little bit more neutrally or negatively tilted as it approaches the southern plains here come Wednesday and Thursday. Let's go down to 850 millibars here, and this is where we are going to look at our low-level jet. You can see very potent circulation here up in Canada, very potent low-level jet associated with that, upwards 60, 70, 75 knots, even 80 knots here up across Canada, stretching into the northeast, kind of northern portion of the country. But that's not going to have an effect on our southern plains Midwest system here. And you might ask yourself, well, why are we looking at the low-level jet? Doesn't that provide warm, moist air? And don't we really look at that only for severe weather events? Well, you're partially right, but it does have a critical, it is a critical player in these winter weather events as far as precipitation type, because yes, it does provide warm, moist advection, but it's going to do so and overrun sort of this colder air near the surface. And when it does that, when you have warmer air aloft above colder air near the surface, you can get a higher potential for freezing rain or sleet, which will have somewhat different travel impacts, infrastructure impacts than just pure snow would. And we'll talk about that in a second. and how we can look and determine what the precipitation type may be for a certain location. But let's go down to our surface map here. You can see very potent, well-defined surface low up here in Canada with a cold front stretching down in this kind of pressure tongue here into the central and southern plains, down here into kind of the Texas South Plains. We do have a little bit of a sort of frontal low right here, located near kind of the Childress, Texas area. Not going to have much of an impact here for our system. But we've got to the north of this front, pretty much we've got some pretty chilly air back here. And you can see some remnants of this really cold Arctic air coming up on our surface map here up into southwest Canada and the far northern plains. And it's evidenced by this surface high pressure. You can see the pressure level here, up to 1034 millibars. That's really, really high, and it's going to even get higher into the northern plains as this cold air surges downward. But this high pressure ridge located up here well into Canada is associated with this really cold Arctic air, and that's going to come down. This front has kind of stalled out here across the southern plains, so more of a stationary front. But as that low-level jet ramps up here overnight and into the day tomorrow and into the overnight hours Wednesday into Thursday, it's going to provide that warm layer of air aloft, and it's going to overrun this colder air, which should surge a little bit. This front should surge a little bit farther south, probably down into the central or northern Texas vicinity, up into Arkansas and the Ohio River Valley. And as that low-level jet overruns that layer of cold air near the surface, you get the chance for freezing rain and sleet. Whereas up here farther north into the cold air, where this low-level jet really can't penetrate as much, you'll just see the temperatures well below freezing throughout the entire atmosphere, and therefore all you'll get is snow and no chance for freezing rain. So let's take a look at that as far as how we can look at soundings for precipitation type. And so these are the three soundings we look at for precipitation type. So we've got our snow sounding on the left, so completely and only snow. Then sleet here in the middle, and freezing rain here on the right side. So for our snow sounding, you'll notice that the soundings kind of are color-coded here. The area that is in red is above freezing. The area in blue is below freezing. And of course, our red profile here is our temperature profile, and that's the one we're going to be looking at. If you're kind of unfamiliar with these diagrams, go ahead and take a look at my SKU-T series that I've been putting out here over the past couple of weeks. It goes into how to read these diagrams and the parameters you can assess from these diagrams. And if you're kind of unfamiliar with how to read these, I would highly recommend looking at those videos. And I'll put a link to that playlist down in the description box below. But here, so we've got our snow sounding here on the left, and you'll notice that the temperature profile is below freezing throughout the entire column. So the frozen precipitation has no chance to melt before it hits the ground. It's going to remain frozen the entire time it descends through the atmosphere. Now for our sleet and freezing rain soundings, which are both quite similar, you're going to see this kind of warm nose aloft here. So you've got this very cold air near the surface, but above that, you've got a layer of very warm air that goes above freezing. So frozen precipitation that falls is going to fall. Once it hits this layer that's above freezing, it's going to melt. But because there's this kind of layer of cold air for a decent stretch of the low levels of the atmosphere, it's going to have the chance to refreeze before it hits the surface into sort of sleet pellets. Freezing rain, very similar, but the warm nose is much deeper. So you either get a much warmer warm nose or a much deeper, you get a warmer sort of warm nose, which allows this kind of the layer in which the temperatures are above freezing to be a little bit deeper here. So that allows the layer of cold air near the surface to be quite shallow. So this precipitation, frozen precipitation that's falling, is going to melt through this layer, but it doesn't have a big chance enough time to refreeze before it hits the surface. So it's going to fall at the surface as liquid. But because the temperatures are below freezing at the surface, once it makes contact with, streets, trees, etc., it is going to freeze on contact with the surface, even though it's fallen as liquid. So that's how we diagnose the precipitation type. And so let's go ahead and look at some of our models here. So this is our precipitation type. This is the brand new GFS run. And just a caveat here, I'm not going to use the NAM to diagnose precipitation type here, because the NAMs, the schemes that the NAM uses to characterize the boundary layer, or kind of the lower levels of the atmosphere, where the weather happens, are very poor for determining precipitation type. GFS does a little bit better job. So I'm going to look at the GFS here instead of the NAM, even though we're looking at kind of a short range time scale. So this is the 12Z GFS here, hot off the press. So you'll notice that we do start out with some precipitation this evening across the southern plains. It is mostly rain until that cold air really starts to surge southward. Up in Kansas into Missouri, northern Illinois, we will see a kind of snow, perhaps a wintry mix area here. Then once that cold air starts to dig down Wednesday morning, and by Wednesday afternoon it really starts to fill in. But we've got these kind of three separate regimes here. So the first one, and this is going to be, I'll stop it right here just as an example. This is going to be 9Z Thursday, or 3 a.m. Central Standard Time Thursday, early Thursday morning. So we've got this area of blue here. So to kind of the north of this blue line here, this is going to be snow, where you see the blue colors. That's going to be all snow. Now below that, to the south, you can see these purples and reds, kind of to the north of this pink line. That's where we're going to see the chance for a wintry mix and a better chance for ice. And to the south of that, where we see all the greens, is where we see only rain. So let's take a look at some different profiles here to kind of match up with what we just talked about with the soundings. So let's take a sounding here from the snow. Let's go southern Missouri. Then let's go to our area of ice, let's say right around, say kind of Durant, Oklahoma area. And then we'll go into the rain area, so maybe around the Waco area. So let's first look at our freezing rain, or our only snow sounding. So this is going to be southeast or southern Missouri here, where we're going to see the GFS is forecasting all snow at 3 a.m. Thursday. So here is our 0-degree isotherm, our temperature line, our freezing line, 0 degrees Celsius. And you can see the entire profile is to the left of this line, or the temperature is, as you go up in the atmosphere, is always below freezing. So as a result, that precipitation that falls is never going to have a chance to melt before it hits the ground, so we're only going to see snow. Now let's go to our ice sounding here. So this was southeast, kind of southern or southeast Oklahoma. And so here's our 0-degree isotherm here. And you can see we do have a little bit of a warm nose here. There is a portion of time, kind of between 750 millibars and about 900 millibars, where the temperature goes above freezing for a little bit. So that frozen precipitation is going to start as frozen. Once it hits this level, it's going to melt. But given that we have a pretty shallow layer of cold air near the surface, it may fall as liquid and freeze at the ground, where temperatures are well below freezing, or it may start to have just enough time to refreeze into sort of ice pellets or sleet before it hits the ground here in kind of the southeast Oklahoma into North Texas area, at least at 3 a.m. Thursday. And then let's look at our rain sounding. You can see that the bulk of the sounding, here's our 0-degree Celsius isotherm. You can see that the bulk of the sounding in the low levels, even below about 650 millibars here, is above freezing. So that frozen precipitation is going to start melting right about 650 millibars, and it's never going to be able to refreeze before it hits the ground. because temperatures are entirely above freezing below that level. So you will see only rain wherever you see this kind of sounding here. So that's how we determine precipitation type. Now, where are these precipitation types going to set up? Well, it's kind of still up in the air. So let's go through. This is just the one GFS run, of course. So throughout the day, Wednesday, about Wednesday afternoon, this is 21Z Wednesday. So this would be 3 p.m. Wednesday. So you can see we've got mostly snow here with northern extent as we go closer to the cold air, where the temperature profile is all above freezing here. So we'd expect to see that maybe the I-44 corridor here from Lawton to Oklahoma City up to Tulsa, anywhere to the north of that, down into the Texas South Plains. Anywhere to the north of that is going to see snow, but it's still kind of up in the air where this sort of freezing line will set up, how deep that warm nose is. You can see these purples here from North Texas into southeast Oklahoma up into southeast Missouri. That's where we have the chance to see ice. So it's going to depend on how deep that warm nose is. If we get a deeper warm nose, or maybe that low-level jet pushes inland a little bit farther, up into maybe central or northern Oklahoma, then we would have a chance to see ice farther north. But if that warm nose is not quite as deep, it's a little shallower, then we have a chance to see snow farther south, and that layer of ice, that ice area, will be a little bit farther south as well. So that's still kind of up in the air. Right now it looks like things are going to set up kind of along the I-44 corridor. So Oklahoma City, kind of on the border here. Some models are showing that it's going to be all snow. Some models are showing it's going to be a mix of ice and snow. But it's up in the air. Now, areas like Dallas-Fort Worth, if I can go ahead and go through time here, evening hours Wednesday into overnight Thursday, that cold air really starts to sag south. And at this point, it's showing Oklahoma City and Tulsa as purely snow, up into Missouri, purely snow. Dallas-Fort Worth looks like is going to have a pretty significant ice period where ice is going to fall, ice is going to occur, all the way down toward Midland into the sort of I-10 corridor here in West Texas, up toward the Dallas-Fort Worth area. Areas like Durant, Ardmore, the southern portion of the I-35 corridor in Oklahoma, up into maybe even the Little Rock area, chance for ice there as well. And then as we go on throughout the overnight hours and the early morning hours Thursday, that ice kind of hangs around, snow through much of Oklahoma, and then finally that front starts to push off to the east. We get some rain in the southeast, continued winter weather effects here into Friday morning through the sort of upper Midwest into the Northeast. So again, it's hard to say, but this is a pretty classic ice storm. Pretty classic ice storm, and it goes along with the conceptual models of ice storms that have been researched. And this is from a paper, Sanders et al. 2013. I've given the citation here at the bottom if you want to check that paper out. But this is the composite sort of conceptual model they came up with for major ice storms in the southern plains and Midwest. They took a look at a bunch of different ice storms, took a look at the background environmental characteristics, and this is kind of the composite scenario that we often see when we see a big ice storm in the southern plains or Midwest. And that's exactly what we're going to see throughout the next couple days. We've got this kind of stalled frontal zone here with cold air to the north, warm air to the south. This low-level jet is going to allow this sort of warm, moist air to overrun this frontal zone, overrun the cold air. And wherever that overrunning happens is wherever we're going to see ice, that warm layer of air aloft above a layer of cold air, sub-freezing air near the surface. You can see our 500 millibar trough axis lagging out well to the west, our surface high-pressure area associated with that cold air here centered over the northern plains. And we've got this kind of upper-level jet axis displaced a little bit to the north of that low-level jet area. But that upper level jet kind of helps enhance the surface features and enhances that low level jet that helps that overrunning process and allows us to get ice here just to the north of this frontal zone into the cold air where that sort of warm nose sets up. So if we go through the models here, this is just pretty textbook. If we go to our upper levels here, 250 millibars, you can see very much what we saw on our composite model here. There are very broad area of strong winds aloft here at 250 millibars. It displays kind of to the north of the main region, main action region, if you will. We go down to 500 millibars, and our trough axis lagging pretty far back here by Wednesday morning. Our trough axis, our main players, is kind of centered over Arizona, Utah, Colorado, or Wyoming. Still very much positively tilted, hanging back a little bit. But as we go through the day on Wednesday, that starts to eject into the plains and take on a much more neutral or even negative tilt by Thursday morning, Thursday afternoon. And then if we go to 850 millibars, you can see that low-level jet. Not as potent as something we'd see with a severe weather setup, but enough to allow this warm, moist air to continue to filter northward. Our frontal zone going to be somewhere kind of right in there. And that warm air is going to continue to be pumped north by that low-level jet. It's going to start to overrun this cold air, and wherever that happens is wherever we're likely to see ice. And when we have these lifting mechanisms that allow continued precipitation to happen, as we can see here through our short waves, our first one here this afternoon and evening, right here across Oklahoma. Then we start to see these other ones here throughout the day, Wednesday into Thursday, little one right there. So these are only going to provide little sparks to allow that precipitation to continue as well as that sort of large-scale background synoptic scale lift from the long wave trough that continues to amplify and become neutrally or negatively tilted. And then our surface pattern, you can see that big swath of cold air here. You can see that surface low that we talked about right up here in Canada moves off. That cold air surges southward, and that surface high associated with that cold air sets up in the far northern plains, the Dakotas into Minnesota. Surface high, cold front down in here, kind of stalls out, but all this cold air behind it is going to be critical in where we're going to see snow, where we're going to see perhaps ice, wherever that sets up with that warm nose aloft. So some of the outcomes are still up in the air, but it does look that with farther north extent, we will see a better chance for purely snow. And there's kind of going to be a sweet spot here where we will see the chance for ice. Now again, we're not certain where that's going to set up. Wherever that warm nose is, if the warm nose is a little bit deeper than expected, so either temperatures are a little bit warmer than expected in the mid-levels from that low-level jet, if that happens, the warm nose will be deeper. We'll see a better chance for freezing rain or even sleet. And wherever that sets up, if it sets up a little bit farther north, that low-level jet pushes inland a little bit more, then the Oklahoma City metro area could be at more of a risk for ice. And areas farther north will be at a little bit more risk for freezing rain and sleet. If that doesn't quite happen, the warm nose is a little bit shallower than expected, a little bit cooler temperatures aloft, but still above freezing, then that ice area will be a little farther south. But again, that's kind of up in the air. It looks like kind of the I-44 corridor in Oklahoma stretching to the southwest and northeast. It's kind of going to be something we'll have to watch, and we'll have to monitor the soundings tomorrow to see how deep that warm nose is and where the freezing line sets up. So this is just from the Weather Service. These are all the winter weather warnings that are out right now. So we've got winter weather. The blue is winter weather watches, winter storm watches. And this area of pink here in Oklahoma is a winter storm warning that has just been issued within the last 30 to 45 minutes or so. So they are expecting a pretty potent winter storm here in Oklahoma. They're holding off here in North Texas. But again, once details are ironed out, we may see winter storm warnings extended farther south here into North Texas, perhaps farther east into eastern Oklahoma and Arkansas. But winter storm warnings here from Kansas into Missouri, Illinois, Indiana, into Michigan, already lofted, and some estimates from the local weather service offices here. Snow 4 to 6 inches for Oklahoma City and Stillwater. Farther south and southeast, 3 to 4 inches, 2 to 3 inches in Ardmore and Durant. Again, that's up in the air. And for ice, there is a chance for Oklahoma City to see some ice, perhaps this afternoon into evening, as that cold air does start to sag southward. And we do kind of see that a little bit of warm air remain aloft. We may see some ice here in central Oklahoma this afternoon. But I think the greater ice potential will kind of set up across south central and southeast Oklahoma. So the southern portion of I-35 in Oklahoma, southeast Oklahoma, Durant, Hugo, Broken Bow. Ice is likely. And then into North Texas. This is from the Dallas-Fort Worth office. Potential for any ice is high. Potential for pretty significant ice is going to be pretty high in North Texas. So Dallas-Fort Worth area up to the north toward the Red River. So Denton, Gainesville, Sherman, McKinney, up toward the northeast, Paris. Those areas likely to see the highest chance for significant ice accumulation, with some chance here going all the way farther south into central Texas toward Waco, Killeen, even Austin down there. And then once the colder air really starts to filter south, there is some chance for snow, especially with western extent into Texas. As that really cold air filters down and the profile becomes below freezing through its entirety, we will see snow for much of north and west central Texas. So again, these things, some details still need to be ironed out. We'll have to watch tomorrow to see kind of the progression of the temperature profiles aloft, but for now, it does seem that there will be some sort of corridor from central Texas, maybe up into southeast Oklahoma, central Arkansas, up toward the northeast, where there will be a chance for significant ice accumulation, which we know has pretty significant travel impacts. Anywhere to the north of that, likely to see mostly snow, and then anywhere to the south of that sort of region, likely to see rain in its entirety. But again, we'll have to watch where that freezing line sets up tomorrow afternoon. Places like Oklahoma City, kind of up in the air as far as the snow accumulation. There is a chance that we will see the dry slot move into west central Oklahoma. So anytime you have these kind of potent troughs, this is at 500 millibars, you will start to see dry air get kind of pulled up from the southwest up, and it comes kind of into the region in the area of interest. And if we do get that dry air to come in, and we can go look at relative humidity here to kind of show you what the dry slot is. The whites and blues are high relative humidity at 500 millibars. The reds and blacks are dry air. And you can see that dry slot really start to punch in by Thursday afternoon and evening here. These reds are dry air, really starts to punch into North Texas, southern Oklahoma. So if this is a little bit faster than anticipated, or a little bit more dry air than anticipated, the winter precipitation totals may decrease here for these regions that are impacted by the dry slot. Now this is one model, not saying that this is going to happen. There still will be significant winter precipitation here for these areas, but it may be tempered if this dry slot can advance a little bit faster or is a little bit more significant than anticipated. So something we'll have to watch through the coming days, as it may have an impact on snow totals and ice totals for that matter. But still up in the air. I would expect something, say 4 to 6 inches is a decent estimate right now. Anywhere from 2 to 6 inches across much of Oklahoma, with ice favored with southeastern extent into North Texas and Southeast Oklahoma. But we'll have to watch it, and this is going to be a potent winter weather system nonetheless. So that's all I've got for now. Hope you enjoyed this video. Thanks for watching, and we will see you in the next one.